This is the walkthrough for the Momentum Lab. So in part one, you're only going to use one device. So for this device, you're going to insert the spring with the screw in it into your force sensor. So normally you have one of these screws with the eye hole in it, so you can take that out and place the one in with the spring in with it. So on your software, you're going to choose the force sensor and the wheel sensor, and you'll just need to look at velocity for the wheel sensor. And there's also a toolbar at the bottom of each graph. It's this little square with the arrow coming out of it. If you click on that, the first drop-down menu is called smoothing. You can click that, and I'm just going to choose 5, and what that will do is it will kind of smooth out the rough spots on your graph, make it just a little bit easier to read. Okay, so what we're basically going to do is we're just going to give this device a little push, and we're going to push on the spring itself. So we'll press record, we'll do the re-zero the force sensor, and then we'll just give it a quick push, almost like a tap. Okay, so you don't want to push on it too long, just a quick little tap. So then we'll zoom in, and what I like to do with my zoom is I like to do the left to right zoom first, and then I'll do the top to bottom. All right, I'll do the same with the velocity. And you're going to want to save a screenshot of this. Now, your data tool is up here above the graphs, and it looks kind of like a bar graph. If you press on that, and then you bring your cursor down over the graph, you notice a line appears. And the upper left hand of the graph, you'll see it's displaying T for time. So as you move that along, you can see at what point in time you're looking at. And then you'll see Fy. So it's telling us, since this is a force versus time graph, it's telling us what the force is wherever we put the cursor. So if I put it over here on the big bump of the graph, we'll see that we're actually getting something. Okay, and if you look at the velocity graph, you'll also see it's the same thing, T for time, and this time Vy, so that's just V for velocity, all right? And the Y is just indicating the Y direction on the device. As we move that around, we can see the different speeds. Okay, so what you want to collect for data for this part is you want the area under the curve during which you were pressing on the device, so during which you pushed it. So it's a very small area, so you're going to take your data tool, you're going to click and drag over whatever area you think it is, and you'll notice that a little area is highlighted on your graph, and some more data appears up top here. And so to get area, there's this one little piece of data that says A, and that's signifying that that's the area of what you clicked and dragged over. Okay, and you notice here it's a 0 because I just clicked on the flat part of the graph where nothing was happening. And you also notice that it's giving you some units. So N times S, so newtons times seconds, which makes sense because this is a force versus time graph. And force times time is a special quantity we call impulse. So you're going to collect that area under the graph, and then you're also going to want to know what was the speed immediately after you stopped making contact with that spring, between the spring and your finger. So you will again go down to your velocity graph, put the cursor where you think it was, and that number will show up right here. Now in part 2, we're going to use 2 devices. So the second device, we're going to insert the screw with the washer in it into the force probe. So then we'll reset everything here, and then we'll click on both remotes. We'll display force and velocity for each one. And if you want, you can go to your toolbar and do the smoothing again, get some nice clean looking graphs. So for this, I think 5 is good. If you do too much smoothing, then it'll just really flatten everything out and you won't be able to see anything. So what you're going to want to do in this part is you're going to want to push your iLab device up against something like a wall or something that's not going to move. If you want, you can use your hand if you can keep that steady enough. On the lab here, I have a little tray with some weights in it, and it's sitting up against some clamps, so it's not going anywhere. Okay, so I'm going to press record. I'm going to re-zero my sensors, and I'm going to push the device into the wall. And you notice that it doesn't take much of a push at all to get quite a bit of force. So I'm going to try to get it less than 10 newtons. That'll give me some good data. I'm going to stop here as I notice that this collision right here at 22 seconds is pretty nice. Let me show you why. So you can see the peak there is almost exactly 3 newtons. Okay, so that's going to be nice later for comparing with the next collision. So then I'm going to zoom in on my velocity graph and use the data tool. So you're going to want to know what was the speed of the device as it hit the wall. So you put the cursor over whatever spot you think that was. So if I put it here, it's saying 0.1 meter per second, right in the upper left-hand corner here. All right, so we're going to record that. We also want to know what's the maximum force that was experienced by the device. So if we put the cursor over the maximum, right here was just about exactly 3 newtons. So we're going to record that. We also want to know what was the average force experienced during the collision. So to get the average force, you're going to do the click and drag again over the area where the collision took place. All right, so wherever you think that is. And then average is going to display up here. So this little mu here is a Greek letter. It looks like our letter U. And that will give us the average force here, okay? And mine's just about exactly 0 because I just kind of highlighted an area where nothing was really happening. Okay, and then you also want to know what's the time interval during which the collision took place. So you have that area highlighted over which the collision took place. You're going to want to look at your delta t up here. Okay, that's going to tell you what the time interval of the collision was. All right, now we're going to repeat this with the device that has the spring attached to it. So we'll click continue, and remember before we said the device hits the wall with 0.1 meters per second. Well, we're going to try to replicate that speed with this device. Okay, so it might take a few tries, and you don't have to worry about being exact. You just want to try to get it close. So I'm going to put my data tool cursor over some areas here and try to find one that's closest to 0.1. So 0.12, so I think that's good enough. So I'm going to highlight that area of the graph. And then from there, I'm going to collect the velocity, and it should be pretty close. The maximum force again, the average force, and the time interval, just like we did for the first collision. Now in part 3, we're going to have both devices again. So I'm just going to reset everything here. And again, we're going to have force and velocity displayed for each. And if I want, I can do my zoom or my smoothing. And then you're going to want to set up your devices in such a way that they're going to collide into one another. So you want to make sure that the force sensors, so the spring and the washer, are going to collide into each other. You notice here in the lab I have some meter sticks, and that's just going to help line up the devices so that when they do collide, they're going to collide head-on. So you don't want them colliding not head-on, because if you hit it and it's at an angle or something, then you'll have to use trig and do vector components. So if you really like to do that, go for it. But I'm going to use my straight edge to make my life a little bit easier. So I'm going to have one device that's stationary, one that's going to collide into the other one. So I'll press record. I'll re-zero my sensors. And then maybe from a foot or two apart, I will push the one and let it collide into the other. Then I'll click stop. Now I'm going to zoom in on the area during which the collision took place. Okay, you're going to want to save a screenshot of these graphs. So you notice in your lab report there's going to be a table for this part into which you can write down all the data you're going to collect. So you're going to collect the mass of each device. You're going to write that down, all right, in the columns for each of the trials. The initial speed, all right, so that's VI, and I have VI1 and VI2, so to distinguish between the two devices. So you're going to want to use the data tool to find out what was the initial velocity of each device before the collision. So that will be your VIs. And then your VFs will be your final velocities. So the velocities of the devices immediately after the collision took place. Right? And then you'll also want your impulses, which are symbolized by the J's. So you want to know what's the impulse experienced by each device during the collision. And then you'll repeat this for the remaining two trials. Okay, you make sure you want to take a screenshot of each of those as well. Okay, so one object is going to be stationary, one's going to be colliding into the other one. So you just want to make sure with these that you have another mass of something that you can put on top of it, that you can measure what the mass of that object is, and then perform those two collisions. And that's it for Lab 3.